Hello. Many of you did not answer the last question of the assignment, so here it is, explain solution. I'm not sure if you didn't answer it because it was the last one and you didn't see it or because you didn't know how to solve it, but just in case, I'm gonna help you solve it. So we have a quadrilateral with corners A, B, and C, and D. We know two of the angles. The angle at A is 120 degrees and the angle at C is 60 degrees. We also know the length of two of the sides, AD and BC as in the picture. And then we have a relation between the two sides that we don't know. It says over here, this is 5 meters longer than AB. So let's say we call AB X. So then CD is going to be X plus 5 because it's 5 meters longer. We need to find the length of a fence that goes all around the quadrilateral. So we need to find the perimeter of the quadrilateral. So we need to find the value of X. So then we are going to see that the perimeter, so that's the length of the fence, is equal to 16 plus X plus 25 plus X plus 5. We can even simplify this to 46 plus 2x, and then our job is to find the value of x. To find the value of x, we are going to divide our quadrilateral into two triangles. Some of you found tempting to divide in this sense over here. So ABC and ACD, but that's not going to work because once we divide in that way, we don't know anymore any sides of any angle because we don't know if the line that we are drawing is cutting 60 in half or cutting 120 in half. Probably not. There is no reason to believe that it is. So that division is not going to help us because then we won't have any information about the angles. So that's not what we want to do. What we want to do is to divide it according to the diagonal from B to D. So now we are going to have two triangles. ABD is the first one. And then we have also the triangle BCD. Those two triangles have something in common, that is the diagonal BD, that I'm going to call it Y because we don't know what Y is. When we get to this point, I know that many students feel discouraged because it looks like we don't have enough information. So there is X, there is Y. How are we going to solve this? We need to find X, we need to find Y. The thing is, we are going to write two equations. One in the triangle AB, the other one in the triangle BCD. And then because we have two equations, it's going to be okay to have two unknowns. And let's just try it. In the worst case, what can happen is that we cannot solve it, but you have to try something, right? So I'm going to try to write an equation for the triangle ABD. And let's say we want to write what is Y. Well, we can apply the cosine law in its first version, and then we can say that the square of Y is going to be given by the sum of the square of the other two sides, so X and 16. So we need to do X squared plus 16 squared, minus 2 times the product of the sides, so times X times 16, times the cosine of the angle between the two sides we are using here, and X and 16, so the angle that is in front of Y. So that's 120 degrees. We can write something similar for the triangle BCD. In this case, Y squared is going to be X plus 5, so that's all the measure of one of the sides, all of that square, plus 25 squared, minus 2 times the product of the sides, so X plus 5 times 25 times the cosine of the angle between x plus 5 and 25, so cosine of 60 degrees. Well, at this point, it would be useful to write what is exactly the value of cosine of 60 degrees. Because this is an exact value. You may have checked it in the calculator, but this is exactly 0.5 or 1/2. If this was not an exact value and it was 0.87, blah, 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 I wouldn't want to write it. But because it's exact, I'm going to write what it is. Cosine of 120 degrees is also an exact value, it's minus 0.5. And note that at the point that you solved this assignment, you didn't really know much about the exact values of some angles for cosine and sine. But now that we have studied a little bit more trigonometry, then you know that these are exact values and you know how to find them. But for now, you could just have done it with the calculator, and that was totally fine. So moving on to simplify a little bit the equations we have over here. We have x squared plus 16 squared, and then this 2 over here is going to cancel with the 0.5. If we multiply 2 by 1/2, that's 1. So they cancel. And then we have a minus over here and another 1. So we multiply minus times minus, give us plus. So what we have left is 16 times x. So that was all we got for the equation applying the cosine law on the triangle ABD. Triangle BCD is a little bit more complicated because of this bracket with x plus 5 over here, but let's do it anyway. So we are going to have x plus 5, all of that square, plus 25 square, and then this 0.5 cancels with the 2 because 2 times 1/2 is 1. So minus, I write 25 times x plus 5. When we get to this point, we need to do a little bit of algebra over here. We need to expand x plus 5, and we also need to apply the distributive property here with this minus 25. So let's get a little bit of space to do this as a side task. So here it goes. X plus 5, all of that squared. That means that we are multiplying x plus 5 times x plus 5. So this is going to be x squared plus 5x, again plus 5x, and then plus 25. So this is x squared, and collecting the like terms, 5x plus 5x, that's plus 10x plus 25. Also, we need to multiply the 25 times x plus 5. Note that there is a minus in front of it, so let's do it with the minus. So it's going to be minus 25x minus 125. That's 25 times y. So with these results, we can go back to the equation of resulting of applying the cosine law to the triangle BCD. And we can write x squared plus 10x plus 25 minus 25x minus 125. And I'm noticing here I missed something. Yes, I miss over here this term plus 25x squared. Let me add it here at the end. So this is collecting like terms. We have the x squared is the only term in x squared. We have plus 10x and minus 25x, so that's minus 15x. And then this is plus 25 and minus 125, that's minus 100 plus 25 squared. Notice that I'm just not doing the work with the calculator yet. I'll do it all together at the end. For now, I just wrote what those two equations are. So what we got is one way of writing y squared using triangle ABD, saying that y squared is x squared plus 16x plus 16x squared. And another way of writing y squared using the arrow triangle, where we got x squared minus 15x minus 100 plus 25 squared. So that means we can get rid of the y squared, because we are saying y squared is equal to something in the first equation, and y squared is equal to something else in the second equation. But that means that whatever we're equaling, whatever we have in the right-hand side, has to be the same in both cases. So what we're saying with these two equations is that actually x squared plus 16x plus 16 squared, which is 256, you can check with the calculator or by hand if you want, has to be the same as x squared minus 15x, and then we have 25 squared, that's 625, minus 100, so that's plus 525. Well, our goal is to solve this for x, so we're going to begin by canceling. We have x squared on both sides, so we can subtract it. And then we can say that 16x plus 15x, that's 15x we have here, the minus 15x we have here, has to be the same as 525 minus 256. So that means that 31 times x has to be the same as 269. So x is 269 divided by 31. If you wish, you can find what that is approximately. That's to three significant figures, 8.68 meters. But we don't need that value for now. But we're just going to check in our picture that makes sense. We are saying that the side AB is 8.68, and then we are saying that the side CD is that plus 5, so 13.68, and all those values are values that make sense in the picture we have. Now, the formula we have for the perimeter to find the length of the fence is 46 plus 2 times x. So 46 plus 2 times x, the exact value of x is over here, 269 over 31. And if you approximate that with the calculator, you will get that the fence is 63.4 meters, approximated to three significant figures.